Imagine this. You're at a massive live event, maybe a concert. The mixing desk is, I don't know, a full kilometer away from the stage.
A long way
A
away.
very long way. And you need perfect, pristine audio. But running that much copper cable, it's an engineering nightmare.
Oh, absolutely. You're talking about noise, interference, signal loss. It's a huge problem.
So today, we're diving deep into the tech that solves this, how to turn high-quality analog audio into, well, light.
And that's the whole mission. We're looking at the thinking behind systems like the Thor fiber audio kits. They changed the entire game. The key takeaway for you listening is really understanding the specs that let pros send studio-grade sound across city-sized distances.
Okay, let's get into the tech itself then. I'm seeing this is a bidirectional system, a TxRx kit.
Yeah, TxRx just means transmit and receive. It can send signals both ways at the same time on one little fiber strand. This one we're looking at is for 4 unbalanced analog audio channels.
And that's where the magic is, right? The conversion.
That's the secret sauce. It supports 600 ohm unbalanced audio. Now, that's a classic standard, but, unbalanced cables are basically giant antennas for interference.
They can pick up everything.
Everything. So the genius move here is that the moment that analog signal, and we're talking a really wide bandwidth, 10 hertz all the way up to 24.5 kilohertz, the moment it hits the box, it's digitized and shot down to fiber as light.
So the noise that copper would have collected just can't attach itself?
It can't. You've eliminated the medium that causes the problem in the first place.
But hold on, copper is cheap. Fiber and these converter boxes, isn't that much more expensive for just 4 channels?
It seems like it would be, but you have to look at the total cost and the reliability. These systems are so scalable. You can get them in 2, 4, 8, even 32 channels.
I see.
And this one small box replaces huge, heavy bundles of cable. More importantly, it solves noise problems that would otherwise cost a fortune in troubleshooting and special grounding. It just works.
Okay, that makes sense. But for live events, for concerts, speed is everything. What about the delay from all this converting?
That is the critical metric, latency. And that's where the engineering is just, well, incredible.
How fast are we talking?
The whole process, end to end, has a latency of only 1 millisecond.
1 millisecond, wow.
Yeah, it's almost nothing. Think about it. If you have a delay of even 15 or 20 milliseconds on a remote mic, you get this horrible echo when you mix it with a local sound.
A phasing nightmare.
Exactly. A 1 minute delay is, for all practical purposes, instantaneous. The sound engineer doesn't even have to think about it.
And you're not sacrificing quality for that speed.
Not at all. The digital side is super robust. You've got a 48 kilohertz sample rate, 24-bit bandwidth. The signal-to-noise ratio is better than 79 dB, which is excellent.
Yeah.
But the distance, that's what really sets it apart.
This is the part that's hard to get my head around. The base unit can do 20 kilometers.
20 kilometers.
Yeah.
On a standard single-mode fiber. Just think about that. Broadcast quality audio across 20 kilometers. And if you need more, the long-haul versions can push it to an incredible 120 kilometers.
That's city to city.
It really is. Even with older multi-mode fiber, you're still getting 2,000 feet, which is way beyond what you can reliably do with copper.
So when we zoom out, the big picture is that fiber isn't just for your internet connection. It's a core engineering solution for professional audio. It delivers pristine quality over distances that were once, basically impossible.
Exactly, which leaves a really interesting question for you to think about. We talked about the system using 600 ohm unbalanced audio, running it up to 2 volts peak to peak. Given how incredibly prone that setup is to interference, just imagine you had to use copper for that same 20-kilometer run. How much money and how much complex additional gear would you need just to try and match the clean signal that this fiber solution gives you right out of the box?